Who was Albert Einstein? Chapter 4, The Best Years. When a person invents something, for example, a battery-powered back scratcher for miniature poodles, the inventor sends a description of the invention to a patent officer. An examiner looks at the idea and decides if it's really something new or just something that's a little bit different from an already invented gadget. If it's really a new idea, the inventor gets a patent, which means that other people aren't allowed to copy it. It takes a very smart person to understand inventions when they're just in the idea stage. Albert was that person. Reading applications for new inventions was like solving puzzles. Albert was so good at his job that each day he completed his work long before it was time to go home. He was then able to turn his attention to his first love, thinking. Imagine what this must have been like for Albert. It would be like a kid going to school every morning, finishing all of his schoolwork within an hour, and then playing for the rest of the day. With all this time to think, Albert ended up writing and publishing more scientific papers. In 1 year alone, he published 5 groundbreaking papers in a very famous German journal about physics. A storm broke loose in my mind, explained Albert. So in some ways, his patent office job turned out to be a lot better than the teaching job that he had originally hoped for. Einstein in 4D. People measure objects in 3 ways: length, width, and depth. Anything, a piece of toast, a TV, a yo-yo, is so many inches high, so many inches wide, and so many inches thick. These 3 ways of measurings are known as dimensions. Albert threw in a 4th dimension, time. Albert said the dimension of time was as important as length, width, and depth, especially when measuring something big like outer space. To think about the size of outer space, but not the time it takes for something to travel through that space, is like thinking about a song without the lyrics. Something important is missing. With a steady work at his patent office, Albert felt that he could ask Mileva to marry him. So he did. She said yes, and they were married in 1903. The following year, their son, Hans Albert, was born. Now Albert had the time to enjoy music, long dinners, and long walks with his family. Albert was happy and secure, confident in his job. He could relax, be more himself. For Albert, that meant dressing carelessly, wearing the same wrinkled shirt day after day, and often forgetting to brush his hair. As someone once said, Einstein looked as if he had just smoked an exploding cigar. Albert's years at the patent office were wonderful. He had a family, time to think and write lots of scientific papers, and enough money. Many of the greatest scientific achievements of the 20th century, electronics, the atomic bomb, space travel, were all suggested by Einstein in the papers he published while he worked at the patent office. These ideas were then worked on further by other scientists in the decades that followed. In 1909, the University of Zurich convinced Albert to leave the patent office and become a professor. Albert would actually be paid to teach and study physics. Life was even more wonderful. Einstein's theory of relativity. In 1905, Albert published a paper about relativity. It said that everything except light travels at different speeds depending upon different situations. Think about relativity this way. If you look up at the sky and you see a plane in the distance, it doesn't appear as if it is going very fast. You stand there and watch as the plane seems to move slowly across the sky. Yet if you were standing next to it, the plane would zoom past you in a speed. Second, blam! Boom! Gone! And yet again, if you were sitting inside the plane, It barely seems to move at all. See how the speed of the one plane can look totally different to you in a different situation? That was Albert's point. The speed of a moving object depends upon how it's being viewed. In a short time, Albert became a very popular professor. College students enjoyed the way he explained different concepts with simple images. Think about this image. A man falling freely in the Earth's gravitational field who drops an object will not notice it falling. And Albert loved to lecture. It is the supreme art of the teacher to awaken joy in a creative expression and knowledge. Albert was invited to speak all over Europe. He was a rising star. Albert accepted other teaching jobs that took him not only to Zurich but to other European cities like Bern, Prague, and Munich. And Einstein thought. Before Einstein, scientists thought that the sun was always in the same place, with the Earth and other planets orbiting around it. Think of the sun and planets as being like your neighbors. Your home is always on the same street. Your school stays in one spot. You don't have to go looking for these places every morning. Albert, however, shocked everybody by claiming that the sun and other stars, the planets, everything, all of the time are moving through space. Think of the parade with bands and floats always staying the same distance from each other, but the whole parade is moving down the street. Albert's theories were startling. For example, Albert claimed that light bent as it traveled through space. This surprised scientists who assumed that light always traveled in a straight line. Who was right? Often a scientific theory cannot be proven, but this theory could be. During a total solar eclipse, the moon blocked the sun's bright light from viewers on Earth. This makes it possible to photograph the light of the stars behind the sun. Albert insisted that a study of those photos would show that light bending as it passed other planets and the sun. All Albert needed to do was wait for 4 years for the next total eclipse. In 1914, many scientists were also excited to see whether Albert's light theory was correct. In 1911, plans were begun to send a group of scientists to Russia to test Albert's theory. Russia was one of the best locations from which to photograph the stars during the eclipse. Of course, 1914 was still far in the future. In the meantime, Albert continued to think, give lectures, and develop his eccentric genius style. Hopelessly absent-minded, he often forgot his apartment keys, even on his wedding night, lost luggage, forgot to eat, and used money as a bookmark, then lost the book. He always buttoned just the top button of his coat. Why? It's simpler that way, he said. When Albert shaved, he used only water, which is a very painful way to shave. So a friend gave him shaving cream. Albert tried it, said it was marvelous, and then went back to using water. Why was that? It's simpler that way, he replied. Questioned about his looks, he exclaimed, "It would be a very sad situation if the wrapper were better than the meat wrapped inside it." What was really amazing was how Albert was becoming popular with people who had no interest in science. With his wild hair, mismatched socks, wrinkled shirts, and pants that were too short, Albert was not just a brilliant physics professor, he was a personality. His mysterious smile beamed from the front pages of newspapers around the world. A genius had unlocked the secrets of God's own mind. People who didn't understand a bit of physics, who didn't know an isobar from an ice cream bar, were fascinated with Albert Einstein. Articles about Albert showed up in many magazines and newspapers. Had TV already been invented, Albert would have been the subject of all kinds of hour-long specials. Famous formula. Warning, hard stuff. E equals mc squared is a scientific formula. It is so short that it looks simple, not much harder than 2 plus 2 equals 4. That's part of the reason the formula is so brilliant. Albert figured out that a very difficult concept could be explained in a very brief way. Make things as simple as possible, but not simpler. E stands for energy, and M is for mass. Mass is the amount of matter in something. Mass is a little bit like weight. The third thing, C, is for the speed of light. Light travels really fast. Ever tried to outrun it? Basically, what the formula says is that when a little bit of mass is changed into energy, a whole lot of energy will be released. That's what happens when an atomic bomb. An atom is split, mass changes to energy, and an incredible amount of destructive energy is released. With the formula, Einstein claimed that all matter, from a feather to a rock, contains energy.